welcome back. This is the video on inheritance. This is one of the pillars of object-oriented programming that I told you in the first video. We'll look at it today. Okay. So inheritance, as I told you already, that is a ability to derive the properties from another. Okay. It can be anything. In programming in Python, we say that if a class is there and it can derive some properties from pre-existing classes, then we called the property as inheritance. Okay, so there might be one class, there might be many classes from which a single class or multiple classes are deriving the properties. There is no limit that how many times we can derive the class or how many times the given class that is already a base class can be derived. But we say that inheritance should be used only when there is a relationship between the two, right? So this is how we do it. What are the main uses of inheritance? I must tell you that it provides the reusability of the code. What do we mean by reusability? If we have written some code already, then we can reuse it by using inheritance. How? We'll include the pre-existing class into our main class and we'll extend the functionalities for our project. Okay. So if we have designed something before also, we can use inheritance to omit the designing this time, right? So it is transitive in nature. So if a class that is already derived can be further derived also. Okay. In real life also, we have seen that they have relationship. Things have relationship between them. So in programming also, if we want to signify the relationships, we can use inheritance. Okay. In this video, we'll see how to create base classes, derived classes, and how to implement them. First of all, the base class is something from which the other classes would be derived, right? So base is something from which the other classes would be derived, and subclass, or you can say derived class, is something that is derived from a base class, right? So I'll use base class for the definition I've told you, and I use the subclass for the classes that are derived, right? It might be possible that base class that is acting as a base for a subclass is itself a subclass for another base, right? We'll do it practically so you understand what I'm trying to say, right? So let's see first how to create a parent class or base class, right? Base class is also called as parent class, so I'll write it here: base class, parent class, right? Or subclass can be also called as child class, right? In general, we use base and subclass. For instance, we can use parent and child as well. Let's create some values. So creating a base class, right, or parent class, we can say that simply writing class. A class name can be something like a person, right? Doing just this, if we derive any subclass later on in this program with this class person, it will automatically become a base class, right? So there's nothing like extra definition to determine that it is a base class. This is, I'm talking about Python 3 and later versions. In the previous versions, you might have come across this type of architecture. The object was defined as a parameter to this class to signify that this is the base class. But in the later versions from now on, we don't require this object inside this. Okay, so object was placed inside this parenthesis to signify that object is acting as a base class to every class. So object can act as a base class to every class. Okay, so this is how you can normally create a class, and later on you can derive it. So let me just derive a function, just define a function into it. Let's say display. Describing display function, and I'll say there are some variables inside it and I'm just printing it. Person, and I'll say name, right? So this is how just I'll do it. I have to describe name equals ABC for now. Name equals ABC for now, and this name I am just printing in the display. Okay. Also I have to define an initiator as well. I have to describe a constructor because I am using a variable and it has to be initialized. So I'll say self.name equals name, and this name I'm getting from the user. So I'll take it as an argument. We have already done it, so I don't need to explain it much. Now it should resolve. Right. So this is name and this is name. Okay. What I'll do is I have created this class, and now what I require to create a derived class. Right. I have to mention name here. That's why it is showing error, because I have to take an argument and then only I can display. Okay. So what I will do is I can call the object and see if the class is functioning or not. Right. So what I'll do, I'll just create an object class person. I have to supply the name. For example, I'll say Ajay, and this will call the constructor. Next on, I will call the display function. Or I'll just call the display function. I don't need to mention it here. I'll just call self.name so that it already mentions that self.name belongs to this class only. This is how we'll do it. If I try to run this now, I'll see Ajay as an output. So this class is functioning well. I have created a constructor function, a display function, and now what I require is creating a base class, creating a child class. So child class is something that we derive from this class. How we'll do it? Let's see. If I create a class, normal class, called as, for example, a person is a student, so I'll create a student. So if I normally create this class, what will happen? So there shouldn't be any parentheses here. Normally if I create the class like this, it will not act as a child class. What I have to do, this child class should belong to a parent class. So belonging of a parent class is always denoted by the parenthesis. Inside this parenthesis, you have to write the name of the base class, which is in our case is person. So now writing it in this way will associate this student as a child to person. Right? This person should be pre-existing, which is in our own program, else the student is a child class. Now what we have to do, we can create another function called as def, for example, a different name. For example, I'm creating this and I'm creating self, and I'll just say that yeah, this function is called, nothing else. Just I'll say student called, right? So I'll say student called, that is it. So now if I try to create an object for this class, what will happen? And next on I'll call this function. Right? If I try to execute it, it says that okay, it's giving me an error that required positional argument 1. Why is it giving so? Because now that we are calling the child class from a parent class, and parent class requires the name to be initiated first, which is not doing here, which we are not doing here, right? So this is not how we do it. So if I just remove the person here, you will see that this will work, right? So if I create a class as a child class, what I have to do, I will have to initiate the constructor of the parent class as well. This is why I did it, right? So this is of person, right? This class is for person. If I'll say that, okay, if I say that nothing, just pass it on, what it will do, it will create this function and will print the function, right? So first of all, we'll have to do it in the constructor function. So if we have to create the constructor function, uh, we'll create an object for the first class. We'll supply all the functions of the first class from that object. what we can do, we can create the object for the second class, and then we can call the functions of the first class using the second class also. Okay, so if I call this function from the second class of the first class, that is display, what will happen? Will anything happen, or it will give me an error once again, right? Let's try to. Okay, again it says that there's nothing called for the person class. I will just define it over here, just define the constructor for here, because I haven't described any constructor for this function. It is giving me an error, right? So in order to execute inheritance, you always have to keep in mind that whenever you are calling a child class, you have to mention for the base class as well. Okay, so you have to mention the constructor for the base class as well. So we'll see how to do this here. Before anything else, we have to describe a constructor function for this. What it will take? It will take nothing, because this function, this class doesn't have any variables. What we'll do, we have to supply the constructor for the previous class, right? The constructor for the previous class has to be called using the class name. We'll have to write the class name of the base class dot, the constructor function is in it, and it requires some arguments. What it will require? It will require a self, that is predefined, right? It will require it, and will require a name, right? We will require a name, and this name has to be supplied by the user. This name has to be supplied by the user. Whenever we create the student class also, we will have to supply the name. I'm supplying the different name. So if you do this and you supply the constructor for the base class, this will work properly. Now if you call the display function from the child class, the display function could be called. If you call the disp function, it could be called as well, right? Because you have supplied the name. If I try to execute it, it says disp, right? I just made a mistake of writing. Yeah, so here you can see Ajay is printed, then Abhay is printed, and then student called. Why it is doing so, I'll explain you the flow of the program. Let's see. As soon as I create the object for person class, it calls the function display, right? So display in this case will be Ajay. So Ajay is printed. Next, we have a subclass for person described by student. As soon as we call the object, the name is now updated to Abhay. Okay, this name is supplied to the base class as well using this constructor function. Okay, so Abhay is now the name. Now it calls the display function of the base class. So it will supply the new name, that is Abhay, which is here, and then it calls the disp function of this class that will print the student called. So whenever, keep in mind that whenever you have to create the child class, you should supply all the variables of the base class as well through the constructor function. Now if you have to make some variables for this class also, what you will say, for example role, you have to take the arguments for base class first as a method of standard. Role can be just 100 for the normal function, and to initialize this role, what you have to say, self dot role equals role, right? And the diff, this function can also print this. Okay, so whenever you will call the diff function using self, remember that you have to use self, then this function can also be used. So initiator of the child class, it not only initiates the member variables of the class itself, but also calls the constructor function of the base class. Okay, so keep in mind that. So now if you supply multiple here, name and a roll number, that is 200, then what will happen? Let's see. So it is also giving me 200 because the this function is giving me the roll number. Roll is initialized by the constructor of the child class, and then it calls the constructor of the parent class. That is how you implement inheritance. In the next video, we'll see how to implement different types of inheritance one by one. Okay, till then, thank you.